Okay, hello. Welcome to Women Who Codes interview prep series. Today we are going to talk about stacks and queues. All right. So for those of you who have, been to our lectures or interview series before, you've seen this a little bit before, so I apologize. But for those of you who haven't, we're just going to give you a little bit background on technical interviews. So this interview prep series is all about the technical interview. And if you haven't done a technical interview before, it is basically designed to get a sense of how you problem solve. So there's a few different formats. You can do a take-home coding assessment where you're given like a hacker rank or some sort of link, and you're at home given a set amount of time to solve the problems. It can be a live coding assessment where you are paired up with a staffer and they're giving you a challenge and you are, solving the problem in front of them online. Or, in the before times, before COVID, you could do an in-person whiteboard interview where you're in front of a whiteboard and you're actually like handwriting what your algorithm would be. So there's various different formats. But the main focus of the technical interview is three different things. First, can you solve the problem, right? Like, do you have the skills to solve this problem effectively? And not only can you solve the problem effectively, but can you do it efficiently? Like, how much time and space is your algorithm consuming? So if you solve your algorithm, or if you build an algorithm and it's like, exponential time, while it may solve the problem, it isn't really great because it's got a lot of runtime. And then also teamwork. How well do you communicate with the person with you? And this is obviously if you're live, but how well do you communicate with the person with you? Like, are you positive? Are you upbeat? Are you explaining your ideas out loud? And even if it's not live, like, are you writing comments to explain where you're going in your code? Like, there's been times where I have not been able to submit like code that runs, and I just like put in comments like, hey, this is like what my thought process is. And I've been invited to next rounds, which is really surprising, but it happened. Okay, so how will this series help you? Well, this interview prep series is basically designed to give you practice so that you can become more confident in your technical interview skills. I truly believe that practice makes confident, and practicing really gives you the confidence to go into the technical interview and really like shine. So that's what this interview prep series is all about. We will alternate between lectures and practice sessions. So right now, this is a lecture, and that's happening on the first Saturdays of the month. And on the third Saturdays of the month, that's when we practice. Oh, and you can network with fellow developers. Yay! Okay, so let's talk about stacks and queues. Okay, so before we talk about stacks and queues, it is important to go over abstract data types. In my opinion, I think you have to really like understand the reasoning behind them. So if you have gone to any of the past lectures, you know that we went super in depth with arrays. And obviously, because arrays are really awesome, they're really easy to understand. You can access all the elements in constant time. You can, update them in constant time. You can insert in constant time. They're just really simple, easy to understand data structures. But they also have some drawbacks, and I wonder if you all know what that could possibly be. So drop in the chat what you think the drawbacks of an array what the drawbacks of an array are. I'll give you like a couple of minutes. Resizing is costly. Yep. Any other ones that you can think of? Finding items. Okay. Any others? Yes. To iterate through them is expensive. Yes. Okay. These are all good. I mean, the main thing that I is such a bother with, yeah, okay, really good one, Shruti. The main one that really bothers me is that arrays are fixed in size, right? Like once you set an array, you can't change the size. That means a couple of things. You have to know, first of all, you have to know how much size you need ahead of time. And perhaps you don't, right? So if you use a lot of space and you only use a little bit of that space, that means you've wasted a lot of space. But if you've calculated an array size that's too small, that means, I think Lindsay mentioned, when you have to create a bigger array and copy all of the items over. And that's really expensive because that takes a lot of time. If you have to do that multiple times, that's really going to slow you down. Um, Also, if you delete elements in the array, you have to shift them over to so that you ensure that you have a continuous array, right? So like if you have like your array, you remove these elements, you need to shift them over to make sure that you have a continuous array. And that act of shifting them over can be really expensive. Um, and, maybe you're processing data and over time you realize, I don't really care about all of the elements in the array. Like I don't need to access every single item at one time. Maybe I only care about the first couple of items, or maybe I only care about the last couple of items that I've been using. And that's where abstract data types come in. So like the name suggests, abstract data types are, I said structures, kind of the same, but abstract data types are data structures that abstract away a lot of the underlying functionality. So you don't care what's going on under the hood. You just want access to your limited methods and the data that you want, right? So an example of this is Python lists. Do any of you here code in Python, or have you used Python before? Just drop in the chat if you have. I hope someone says yes, because a lot of the code that I use is in Python. Okay, so a couple of people have. So if you've ever used Python, you know that there's no such thing as an array in Python. Instead, we use list. And when you use list, you're just adding elements. Like you're just adding and adding elements. There's no limit. You just keep adding elements. And it sounds really good, right? But what's happening on under the hood is Python lists are actually dynamic arrays. So what's happening is that there's an array that's being set, and then as you reach the capacity, it creates a new array, and then it copies the items over from one array to the other. So if you ever check the runtime on your Python list, like as you keep appending to the list, every now and then, like all of a sudden, it just takes a lot of time. And that's because underneath the hood, you've reached the capacity and it's copying all of the items over. And that's because Python lists are an abstract data type. It's abstracting away a lot of the functionality that's going on underneath. Other examples are graphs, trees, and of course, stacks and queues, which is what we're going to talk about today. So that's just the background of why stacks and queues are necessary, because we want a very limited amount of functionality for our specific purpose. And I'll explain more about what that means. Okay, so stacks. So stacks, I like to conceptually think of stacks like a stack of pancakes, right? So if you're ever eating a stack of pancakes, a stack of pancakes is, pancake laid one on top of each other until you reach the top and you've got your last pancake. Now, when you're eating a stack of pancakes, you don't care about the pancake at the bottom, and you don't really care about the pancake in the middle. What you care about is the pancake on the top, because that's the one that you're about to eat, and you're going to eat one by one, right? So you're going to go top down. And that's kind of like conceptually what a stack is. Another example is a stack of dirty dishes. Like if you imagine that you're going into your kitchen, for whatever reason, you've just got dishes all over the place. So what do? You likely stack the dishes one on top of each other so that it's easy to organize. Now you're not, when you wash a dish, you're not going to pull a dish from the middle. You're not going to pull it from all the way at the bottom. You're going to pull it at the top, from the top, right? And you're going to access the dishes one by one until that stack is empty. So that conceptually is what a stack is. You take your elements and you stack them one on top of each other, conceptually, not like physically. Although maybe in the memory stack. Anyways, yeah, there's a stack, but like you stack elements on top of each other, and you pull the top one by one. So the main functions that you are using when using a stack are push, and that's pushing an element on top of the stack, and pop, and that's removing an item from the top of a stack. So stacks are what we call last in, first out, or LIFO. So the last element to be placed on the stack is the first one to go out. You can build a stack with a linked list or an array. Personally, I prefer using a linked list, and you'll see why in a moment. And some common use cases for stacks are parsing questions. So like a common one that you'll see is like, hey, is this parentheses valid? And it's going to have like all these sort of like parentheses, and you need to figure out whether or not it's a valid set of parentheses. And the easy way to get that done is through a stack. Another one, it's like, evaluate this arithmetic expression. So maybe you've got like, 5 times 4 minus 3 times 8. And you have to keep in mind like, the order of operations, and stacks are a really great way to do that. Maybe it's like, evaluate this like, infix or postfix like expression. Stacks are really great for evaluating those. Stacks are also really great for evaluating recursive operations. So if you have gone to our last lecture where we talked about depth first search and breadth first search. So depth first search uses recursion. Well, you can use recursion. I prefer to use recursion, but you can also solve it using a stack. So that's something that a stack is useful for as well. Okay, so here is the basic implementation of a stack using a dynamic array. On the left, this is using Python. Python, if you don't use Python, it might seem a little awkward at first, but Python is really, I like explaining things using Python because I feel like it's the closest to pseudocode. So if you look a little bit closely, you can kind of understand what's going on. So when you are making a stack, you have your items, and when you push an item onto the stack, you just append it to the list. Or if you're using like Java or C++ or whatever, you just insert it into the array. And then when you need to pop an item, you just remove that item from the remove it from the array. And by remove, I mean just return it. You don't have to actually delete it. You just free up that space. And that's why I have this this index value here. If you're using Python, you don't really need the index value because there's an already built-in pop value for you. But if you're using an array in Java or C++ or whatever you're using, you want to use that index because you want to grab that specific value. And then you also want to change the value so you know where you are in the element, and because you're reusing the same space in the array. Peek is also a really great method to use, and that's basically just showing you the last value of the stack or the top value of the stack without actually removing it. So you can check, oh, hey, what's the top of the stack? Okay, let's continue. Is empty is also a really great method to use when implementing a stack. And as the name suggests, it just tells you whether or not the stack is empty, because you don't want to pop from an empty stack. So over here, I've got some Java, and that just shows you a little bit of what it looks like when you're using a dynamic array with a static array. So as you can see here, I hope you can see my cursor, but there's this push function here, right? And it's basically the same thing as the push function in Python, except when you reach the end, so when the last value reaches the end of the array, you create a new array. And if you look at this create new function here, what it's basically doing is it's creating a new array, and then it's going through the old array and copying the new values over. So that's the dynamic array aspect of a stack in other C-based languages. The reason why you don't see that here in Python is because lists are dynamic arrays, so it hides a lot of that under the hood action from you. Okay, and here is a stack using a linked list. Super easy. You just create, if you know how linked lists work, you create a head, and as you create first a node, right? And so your node has your data and the next value, and you create a head, and it points to the top item of the stack. And as you push another item onto the stack, you just link that new item to the head, and then you change the pointer to point to the last item. And when you remove an item, you just change the pointer to move to point to the next item, and then you remove and like sever the tie and return that item. So that's how that works with a linked list. And this is the implementation here. I didn't put Java in here because it's pretty, I think, easy to understand looking at Python, and there's no need to resize. Okay, so stack operations, like we discussed, push is constant runtime, pop is constant runtime, peek, constant runtime. And the difference between pop and peek, popping is removing the item, so it shows you the item and it removes it. But peeking, you're just taking a look. You're just taking a peek at what the last item is. Is empty, constant time, just determining. But resizing, that is linear time if you're using a dynamic array. And that's kind of why I prefer using linked lists when using stacks. Okay, example time. So here is remember that common problem I mentioned in why you would use a stack? So one of them would be, can you determine if a parentheses is valid? So given a string S containing just the characters, left parentheses, right parentheses, yada, 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 determine if the input string is valid. So how would we go about solving this problem? And I'm actually going to ask this to everyone here today. Can you think of what you would do to solve this problem? And I'm actually going to start sharing my my iPad here so we can go over it. Oh, what? Where aren't you? Uh-oh. Try this again. Uh-oh. I'm assuming you can't see my iPad. Uh-oh. Let me try this. Sorry, y'all. Not sure what's going on here. Okay, well, I'm going to continue without showing it. Or maybe I'm going to try using it like hand drawing with my fingers. Let's see.
So right now we can see like a black screen that says that you've started screen sharing, but we can't see what the screen is. At least that's what I see.
Yeah, that's so weird. Okay. No, why is this happening? Yeah, I don't know what's going on. Okay, so I'm just going to, it says whiteboard here. Can you see this? Hi.
Yeah.
Okay. This is definitely not ideal, but we're just gonna go with it. Okay, cool. Gosh, this is not like what I had imagined, but okay, so the parentheses, oh gosh, with my fingers. So here's what it looks like. Let's get this out of the way. But any ideas from any of you all how we would use a stack to solve this? I mean, no worries, I will show you, but just wondering. Oops, nope. Undo. Do that. Do that. Do that. Okay. All right, cool. So let's just do it. So how do you know when a parentheses is valid? Go ahead and drop. This is a question, like an actual, not a rhetorical. This is a question to you. How do you know if a set of parentheses is valid? Like for instance, I'm going to draw this right here. Okay, that's an open square parentheses and a left parentheses in case you don't know. Is that valid? Okay, yeah, if we have both opening and closing parentheses. Okay, so why is this not valid? When the opening and bracket, they aren't of the same type, correct? There's one more reason that I'm looking for. Or I'll demonstrate. Let's say we'll have matching parentheses and just let me draw. Okay, so this is my parentheses. This is my entry. Is this valid? Aha, it has to start with an open one. So you've all said great things. So first, it has to start with an open parentheses, and it has to have both an opening and closing parentheses. That's correct. They have to be matched of the same type. That is also correct. And the opening parentheses should come before the closing. Exactly correct. Another one here. What about that? Or no, I'll make it a little bit more clear. What about this? Is that valid? And if not, why not? Exactly, right? So there has to be a pair. So theoretically, when we're using this, everything should be cleared out, right? Because if we should match, there should be matching parentheses. So I'm going to show you my hypothetical stack, my conceptual stack. This is my stack. I put it in this box. And so here's what's going to be our algorithm here. If it's left, we'll push. I'm so mad at my iPad right now. If it's left, we'll push. If it's right, okay, we'll just put R. We're gonna pop and see if it matches. And at the end, everything should be empty. That's gonna mean empty. So, and that will help us determine if it is a matching or valid parentheses. So once it's left, we push. If it's right, we pop it to see if they match. And if they don't match, we return false. And at the end, we'll see if it's empty. And if it's not empty, then we return false. Otherwise, it's true, it's valid. So let's go ahead and evaluate this. So this is our stack. And we've got our left square bracket here. So we push. We've got our left parentheses here. So we push. Now we have our right parentheses. So let's say this is like our pop area. Okay, so we pop, and we return our pop value here. Does this match this? It does. So we go ahead and continue. Okay, now we've got a right one. So we pop. And here's our pop area. Does this match this? It does. So we continue. This is left, so we enter it in the stack. This is right, so we pop. Oh my gosh. The funny thing is I had extra time for you all, and like now it's going to be totally eaten up by this by this demonstration. Okay, so does this value match this parentheses value? It does, so we continue. This is a left bracket, so we push. That's another left bracket, so we push. Oh, good. I think I accidentally erased that because I think those matched. This is a left parentheses, so we push. Let me cross this out. This is a right parentheses, so we pop. And this is our pop area. Does this match this? It does, so we continue. Left parentheses, we push. Right parentheses, we pop. I'm just going to reuse this. Does that match that? It does, so we continue. Pew, get out of here. Okay. Right parentheses, we pop. Pop. Does that match that? It does, so we continue. Oh, no, no. Left parentheses, push. Right parentheses, pop. So we pop this, and let's remove this. And this is what we put. Does that match that? It does, so we continue. And let me just be clean about this and erase this. Curly bracket, we pop. Does that match that? It does, so we continue. But hey, we are done. So now we check, oh my gosh. Now we check to see if our stack is empty, and it is. So we return true. Let's try another example. Pew, pew, pew. Okay, let's try, okay, let's try something like this, right? One right parentheses, one left parentheses. Okay. Right parentheses, we pop, there's nothing there. No match, we return false. Okay. Now let's try left parentheses, right parentheses, curly bracket. Okay, so we push a left parentheses there. We have a right parentheses, so we pop. Does that match that? It does. So we are continuing to evaluate. And now we have a left parentheses, so we push. And now we're done. So we check the stack. Is it empty? No, which means we have non-matching parentheses. So we return false. And that is essentially how you can use a stack to evaluate parentheses. And that's really just the basic implementation of stacks, right? Like this is how you would use a stack. Okay, let's stop, or let's do a new share and go back to here. Not demonstrating on my iPad. All right, let's go over cues. Okay, so cues are like, you can think of them like English cues or American waiting lines. So if you're ever at the grocery store and you are, going to the checkout line, you're waiting in a queue. First person to go into line, first person going into line is the first person to get served. And once that first person is served, the person after them gets served as well. And like stacks, we don't care who's in the middle of the queue. Sometimes we care who's at the end of the queue. But really what's most important is the person at the front of the queue because they're about to be served. Queues are first in, first out. And if you've ever stood in line, you know that conceptually, right? So the first person to stand in line is the first person to get served, et cetera, et cetera, et cetera. And they're served in order. And like stacks, you can build queues using linked lists or arrays. Queues are a really good tool to use when you need to process things in order. So if you remember the last lecture that we did, we use breadth first search to go to figure out if there was a path from one point of a graph to another. And we use a queue to process the nodes of the graph in order. So that's an example of what you would use a queue for. The main functions of a queue are enqueue, which is putting something into a queue, like enqueue, enqueue, and dequeue, which is removing things from a queue. Okay, so before I go over the implementation really quickly, there are other types of queues, specific types of queues. Like one is a deck, which is a double-ended queue. Which means that you can enter at both sides. We're not going to go over that today because that's just going to take a lot of time. And there are other types of queues like priority queues, which is actually pretty important. I'm thinking maybe I might do a part 2 to go over that. I'm not sure yet. But the important thing to take away from that is definitely take time to go over priority queues because they might come up in technical interviews. And so it's a good thing to practice. Maybe I should do a part 2. I don't know. Okay. So queue implementation using a dynamic array. So you have your set of items. This looks a little bit weird just because I'm trying to kind of recreate it like you would with Java or C++ or like any like C-based language because Python uses dynamic arrays or lists. You don't really have to have a capacity or resizing or anything like that, but I'm trying to, show that through here. So you have your self.items, which is your list of items, and you have a capacity because if you're using a C-based language and you're using an array, there is a capacity that must be set. If you have there's an is full, you have your front pointer, which points to the front of the queue, and you have your rear pointer, which points to the back of the queue. There's a method that's helpful, kind of like the is empty for stacks. You have is full. Have you reached capacity is the queue full. Is empty again. Enqueue, entering in the queue. Dequeue, removing from the queue. And then your front and rear pointers. Now, wait, what? If you look inside these, the enqueue function, it's not, and the dequeue function, it's not as intuitive as the stack is because we've got this like you've got this like rear pointer +1 and then module capacity. Like, what the heck is that about? And there's a reason for that. Why queue implementation is super complicated. It's not super complicated. Okay, I'm being dramatic. It's pretty tricky. Okay, and here's why. So when you're using queues, okay, if you're using a stack with a dynamic array, it's super easy. But when you're using a queue, it's actually pretty tricky because you are removing from the front. Let me actually explain that a little bit more clearly, hopefully. So see my hands. So when you're using an array and you're using a stack, you're removing from the back. So you're entering or you're inserting items from the back and you're removing items from the back. It's totally fine. But when you're using a queue, you're actually removing items from the front and you're inserting from the back. So if you have a static array, at some point you're going to reach the capacity of the array, but because it's a queue and you're moving from the front, you're going to have all these gaps that basically, fill up the array. And so you can't just like say, hey, it's full, that's it, like game over. I mean, you can, but that's going to be a total waste of space. So hence why queues are a little bit trickier. So queues use something that's called a circular buffer. And basically what that means is we change the pointers for the front and the back depending on how much, depending on if there are gaps in the array. So here's an example really quick. So at the top of this graphic here, we've got this lonely 3. And the reason why the 3 is lonely is because it was the last item of the queue, and we dequeued, right? So we removed items from the front of the queue, and it's the last one left. If we add the elements, if we have the elements 6 and 4, it fills the queue up to capacity, but there's still room at the front of the queue. Now, if you remove the elements, if you dequeue twice, you remove 3, you remove 6, now you've got your lonely 4, and it looks like it's at capacity, but you still have this whole like front of the element. So what we do is we actually reuse it, we reuse the space, and we insert items at the front. So basically what happens is that the queue wraps around the array, right? And that's what this arrow here kind of demonstrates. So the queue starts at 4, but then it wraps around back to the front, the first position of the array, and then it continues. But if your queue is wrapping around, how do you know where the front is and where the back is? And what's really neat is that you can always find the next item with the index of the current item plus 1 and then modulo size. So for instance, this is a, let's see, 1, 2, 3, 4, 5, 6. Oh, no, sorry. 0, 1, 2, 3, 4, 5. So if you were to remove 4, right, DQ, and you want to know what the new front is, you have the current index is 5, you add 1, so it's 6, and then you modulo size. And the size of the current array is 3. So 6 modulo 3 is 0, because if you divide 6 by 3, there's no remainder. So it's 6 modulo 3 is 0. So that means the new front is 0. And if you look here, it is. 0 is the index of the next item, which is where you would set the front. If you were to DQ 2, which we do in this picture, sorry, I'm always like not verbally communicating this clearly. The current index is 0. And the next index is 1. So 0 plus 1 modulo size, which is 2, is what did I say? 0 plus 1 is 1. Modulo size, the size is 2. So 1 modulo size is 1. So what is left over when you divide 1 by 2? Like computer science divide, not truly, no like 0.5, but what is left over when you divide 1 by 2? 1, because it's not divisible. And as you can see, the next index here is 1. So that's why when you're looking at this implementation, there's this, module here, is because it's recalculating what the new position is and accounting for, gaps in the array and using a circular buffer. Okay, hopefully that makes sense. But if not, feel free to drop a question in the chat, and I'm trying to keep it in mind, and I'll be able to answer that question for you. Okay. But here's our friend, the linked list, which is why I said I love linked lists for using stacks and queues, because you don't have to worry about that. When you're using a queue with a linked list, you have a pointer to the front, you have a pointer to the rear, and if you need to insert, you just insert at the end of the queue, and if you need to dequeue, you just remove and change pointers. No need to resize, no need to do any of that. It's pretty easy. Let's see. Okay, so NQ is constant, DQ is constant. Showing you what the front item is constant. Showing you what the rear is constant. Is empty is constant. I didn't add this, but is full is constant. If you use a dynamic array with queues, which you can, I just didn't do because I don't. It just gets a little complicated for me. The resizing function would be constant, or not constant, linear. but you can use linked list to keep it constant. Okay. Is there a big time difference between linked list versus dynamic array implementation for Q? Yes, because with linked list, you never have to resize as you keep going, right? Because linked lists, how they work is that it's not like a continuous stack. It's not like a continuous memory cell like it is with an array. It's your nodes are located at different locations, and what you have in each node is a pointer to the next location. So you never need to resize like you would a dynamic array. Dynamic arrays, when you're copying, yes, dynamic arrays, when you're using the NQ function and you have to resize, resizing and copying all of those elements over is going to take constant time. And that is really the difference in runtime between using a linked list implementation and a dynamic array implementation. The act of copying all of those items over, that is like not even like big O of n, it's going to be theta. Like it is like linear time because you have to go iterate through each item and copy it over. So it gets to be a little bit expensive. In the implementation that I gave you today, hey, go to the left. What's going on? No. Okay. In the implementation that I gave you specifically, I just had an is full function. So you reach a capacity and that's it. Like you set your capacity here and then you reach it and then that's it. And then you reuse the space. So in this particular one, you're actually going to be constant time all the way because you reach you set your capacity, you reach it, you reuse the space, that's it. So hopefully that makes sense. Okay, so let's go ahead and practice. Yay! I'm going to go ahead and look to see how much time we have. It's 11. I feel like this is good amount of time, right? Do we have enough time for everything now? Because if we give you, I think we'll give you 50 minutes. You'll have 50 minutes to implement your code this time, kind of, depending on how long it takes for me to explain this problem. Okay, so I'm going to really quickly stop sharing, or I am going to share, but I'm getting a little messy here. I'm going to stop sharing real quick. So we have, no, this is what I'm going to do. Do you all still see this? My slides?
Yep.
Okay, perfect. Okay, so what we have right here is we have what we're calling our whiteboards. And so hopefully you have already made a Replit account, but you can use this to go to this link here, and you're going to be placed into different groups, into different breakout groups, and the number group that you are in is which board you will use. So if you're group 4, this is the problem, and we've got this fill out here to help you go through each part of designing your algorithm. If you have a Replit account, I recommend one person being the driver. And so what you can do is one person is the driver, and then you can go up here in the upper left-hand corner. If you see the share button, you can share it, copy and share it, and then you all can work on it real time. And so that's what you can use to implement your code. So if you see like this run, it's going to take a moment because I don't know why it takes a long time with Java, but it takes a moment and it runs the code. And oh my gosh, in 3 years, it will say hello world. I promise it's not going to be this long when you run your code like after the first time you run it. Okay, so let's go ahead and go over the problem. So asteroid collision. We are given an array of asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size, and the sign represents its direction. Positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. All right, so here are some examples. 5, 10, -5. The output you should return is 5, 10. Example 2, 8, -8. The output you should return is an empty array because they collide and explode and blow up each other. I'm going fast with this because I'm going to show you more specifically what these examples are. Okay, 10 to -5, output should be 10. -2, -1, 1, 2. Your output should be the same array because these asteroids will never meet. Okay, so what the heck does this mean? Let's do a share, and I'm going to go back to this whiteboard. Okay, clear all drawings. Okay, so let's see, 5, 10, -5. Okay, so 5 is positive, so it's going to the right. Pew. 10 is positive, so it's also going to the right. Pew. -5 is negative, so it's going to the left. And what happens? They're going to crash. But -5 is smaller, so only -5 blows up. No, don't clear all. Clear this one. So what do you have left? You have 5, 10, right? Do you understand that? I'm going to do another one, but just drop in the comment. Oh, sorry, there was like an actual question here. Would you recommend using Python in an interview because it requires less code and syntax? I definitely would recommend using Python in an interview. I actually use Python in all my interviews. And what I do to get over like the sort of under the hood runtime complexities is I just acknowledge. So I say, hey, by the way, I know that this is using constant time every now and then. On average, this is constant time, but I know that there is linear time, and just acknowledge it so that they know that you know. But Python is just in my opinion, Python is so easy that I typically use that. It's so easy for me to build an algorithm in Python, and so I typically use that. Keep in mind, there are some interviews that specifically want you to code in specific languages because that is the language that they use. So like I did an interview with PlayStation where Jillian works, and they use a lot of Java. So like I can't just be like, hey, can I use Python? Like they would be like, no, use Java because we use Java and we told you we use Java. So if it's dealer's choice, coder's choice, I tend to use Python just because it's simple. But also keep in mind that some people use specific languages. And if you use Python and you know that there is some under the hood implementation that's eating up some runtime, just say, hey, I know this could be faster, but I'm just going to code this right like this. And then maybe they'll give you time to fix that. But they just want to know that you know what's going on. That's just what I found. Okay. But did you understand this example? I'm going to go through another one. Okay, let's see. Another one is -2, -1, 1, 2. Okay, let's draw that. Pew, pew, pew. Uh-oh. Matt, can you handle her? Okay, so we've got -2, -1, 1, 2. I don't think that's what the problem said, but that's what we're just going to do now. Okay, so we got -2. -2 is going to the left because it's negative. Then we've got -1. going to the left, it's negative. They're not going to crash because they're both going to the left. Oh, wait, no, I did that wrong. Well, actually, it's fine. We'll just do it this problem. Now we've got 1 going to the right, but it's going afterwards, right? So it's actually not going to meet because they're going this way. And now we've got 2 going to the right. So what do we have left? We have exactly the same thing because they never met each other. So we output this. This is the array that we output. Okay, do you all understand? Or how about this? Who needs to see another example? Or would you like to see another example? I'm going to take that as a no. Okay, I'll do another one. Okay, so let's do 10 to -5. And instead of me just saying it, I'm going to have you tell me. Okay, who said they wanted one more? Jean. I'm gonna pick on you. Okay, so we're gonna go through and we're gonna work this out together. So don't feel pressured. Okay, so we've got 10 to -5. No, yeah, okay, 10 to -5. Oh, I wish my iPad was working, but such is life. Okay. Okay, so Jean, we've got 10. Which way is that one going? You can drop it in the chat. Or anyone, really. I don't have to just pick on you, Jean. Okay, so it's going to the right. We have, yes, exactly. 10 is positive, so it's going to the right. Now we have 2. Where is it going? It's going to the right. Does it crash with 10? No. Why not? Exactly. They're moving in the same direction. Perfect. Okay, now we have 5. -5. Which way is it going? It's going to the left. Does it crash? Let me put this here. Does it crash with an asteroid? Yes. Yes, it crashes with 2. Which one blows up? The 2. Why does 2 blow up? Exactly. The absolute value of 5 is greater than the absolute value of 2. So this one blows up. Pia! Okay, it's done. It's dead. Okay. Now we've got 10 and -5. What's happening here? What happens? Do they crash? Yes. Why do they crash? Exactly. They're going in opposite direction. And which one blows up? Exactly, 5. Because exactly. The absolute value of 5 is less than the absolute value of 10. Psha, that's it's blowing up. Okay, we're at the end of the array. What's the output? Exactly. So final output is the final state of arrays the final state of the asteroids after everything is done is 10. Yep, good. We good? I think we're good. I think you all solved that pretty well on your own. Yeah? Okay. I'm going to keep on moving here. So for sure. Okay, so now I'm going to share this screen again, and I'm going to drop the link for, wait a second, yeah. I'm going to drop the link for, let's go to the chat. Okay, so here is where you're going to find your whiteboards, which is really Google Docs. And we're going to break you up into different rooms. So you have about 45 minutes to solve this problem. If they have equal absolute values, they both blow up. And by the way, when you go into your groups, the problem will be here. So you can just scroll through. I'm also going to drop a couple more links real quick. And it's going to be the implementation of both. Okay, it's going to be the implementation of both stacks and queues, and in both Java and Python. So you all can see, okay, get out of here. You all can see it, so don't change it, just copy it if you need help. Okay, I think we're ready. So, can someone break us up?
Yep.
Okay, cool. So we're back. How did everyone do? What were your thoughts on this one? Drop it in the chat. Were you able, okay, so here's the question I want to know. Were you able to implement your code? Still deciding if queue or stack for output. Oh, for output. For output, it's just an array. But for implementation, we will go for that. So how many people used a stack? And how many people used a queue? Stack, stack, stack. Okay, yeah. So I actually have the ability to share my screen. Okay. Wait. Do you see my screen? Oh, I have to tap mirroring. Okay. Do you see my screen?
Yes.
Okay, let's go. So yeah, the way that you do this, actually, let me go back to this screen real quick, so you can see what this is. The way that you do this is using stacks. So just reading this real quick. So if you have, the way that you know a row of asteroids is stable is if there are no more collisions. When you add a new asteroid, there may be a collision. And if there is a collision, they happen from right to left. So that's actually really perfect for a stack. So if you have a new asteroid at the, oh, I'm just gonna show this. I don't want to read this. Let's do this one more time. Airplay, mirroring, boom. Okay, cool. So if you have an asteroid, right? So we've got, like, let's say, oh my gosh, come on. Okay, you should be working. There we go. Okay. Okay, so you have, like, I don't know, like 5, 10, -5. So when you have a new asteroid coming in, that's depending on what happened in the last asteroid, that determines what sort of action there is. And that behavior is perfect for a stack, right? Because when you're using a stack, you care about the last element in a list, right? So like if you've got something super long, like Ooh, actually, let's do this. All of our examples are short, but let's do like a really long one for funsies. So 10, 5, -8, -2. I don't know. No, let's make it longer. So let's do like 10, 5, -2, -8, 7, 14, -12. Okay, cool. So when you're at this, when you're like in your stack, right? Like say you had like, a whole bunch of numbers here, and as you're processing this array, you don't care what's going on in the middle, and you don't care what's going on at the front. The only one that you care about is the last one, because that's what's determining whether or not there's going to be a collision. So that behavior is completely perfect for a stack. So here's how you would process this. Beep, 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 beep. Okay. So you push something into the stack, and the next time you see a value, you peek. And if they're going in the same direction, you just push, right? Because there's no collision. But if they're going into the opposite direction, then you evaluate. And whoever is the winner, you push back onto the stack. Let's see on here. Not sure that means. Okay, so let's evaluate. So we've got 10. Nothing's happening here. We just push it onto the stack. Let's do another one, 5. Well, okay, actually, before we just push it. Okay, so we have 5. Let's peek at our last value. Is it going in the same direction? It is, so we just go ahead and push. Let's do our next value, -2. Is it going into the same direction? No, it's not. It's actually going in opposite directions. But 5 is greater than 2, so -2, the absolute value of 5 is greater than the absolute value of -2. So this explodes and we just continue on our way. Now we have -8. Let's take a peek. 5, the absolute value of 5 is less than the absolute value of -8. So what do? We pop, because that one explodes. And so now we go ahead and take a peek. The absolute value of 10 is greater than the absolute value of -8. So we just continue on our way. So this is out of here and we go. All right, let's take a look. 7, we take a peek. 10 and 7 are going the same direction, so we just push. Nothing happens here. And then now we have 14. We take a peek. 7 and 14 are going the same direction. That's fine. Oh, I should have done something else, because let's do like -15. I don't know. Make this more fun. Okay, so we just push. Okay, now we have -15. We take a look. The absolute value of -15 is greater than the absolute value of 14, so we pop. Now we take a peek. The absolute value of -15 is greater than the absolute value of 7, so we pop. Now we take a peek. The absolute value of -15 is greater than the absolute value of 10, so we pop. There's nothing left, so we just push. And that's what we have. Once you have your array, so like say you have your array, your stack, then you would pop the value and insert accordingly. So, oops, oh, we've got some chat messages. Okay, cool. You guys got that handled. Okay, so I'm going to stop the share and go back to here. So do you all get how this works? How you use a stack to solve this problem? Drop in the chat. Okay. Jean said, oh no, we're at 12. No. Okay. So we're out of time. But if you have questions, feel free to drop it. Oh, okay. So with the code, I actually posted it here. We have the Java implementation and the Python implementation. So definitely, I'm going to post the link to these slides. So definitely look at these and work through the code. I don't have time to do a live implementation, and I apologize for that, but I think just work it out at home and you'll be able to see the implementation. Oh, I will post it in the meetup like comments. So when I posted you all and I was like, hey everyone, don't forget to make your repline and whatever, that's in the meetup event and you'll get a message that I posted it to you. And I'll do that right away. Okay, so we are out of time. I'm going to pass it over to, I believe, Michi, who will tell us additional events. But before I do, I just want to say, practice, practice, practice. Practice definitely is the difference maker when you're doing your interviews. And I do have some links here for practice resources that I really like. So please use them. Please practice. Practice will help you build confidence and your skills so that you can crush those interviews. Okay, cool. Passing it over.
Awesome. Thanks, Kat. And thank you everyone for coming out today. I'm actually going to stop the recording before we talk about the next events. But before I do that, just round of applause to Kat for leading another great interview prep. And this will be posted on YouTube so that you guys can review separately or later if needed.